To help us talk about some simple forecasting tools, let's visit Sweet Dee's Brownies. One of the reasons Kiana, Sweet Dee's founder and president, launched Sweet Dee's Brownies was to fight the battle against boring brownies. Sweet Dee's motto was, "Life is too short to eat bad brownies." Kiana is thus on a constant quest to bring new, tantalizing flavors to market. One of the new fall flavors, Dallin, Sweet Dee's director of R&D, wants to test is a ginger snap brownie. To decide how many ginger snap brownies to bake on the first day, Kiana and Dallin decided to use demand data from the recently launched pumpkin spice brownie. After an okay start, the pumpkin spice brownie became a big hit. Kiana and Dallin hoped the ginger snap brownie would follow the same sales trajectory. Not sure which forecasting tool to use, Kiana suggested, let's start with the easiest time series technique, the simple moving average. How does a simple moving average work? You simply take the average of several recent time periods of demand. How many periods of historical demand should you use? The answer depends on how sensitive you want to be to new emerging trends. If your demand pattern contains occasional noise that is not representative of real trends, you include more periods of demand data. Simply put, using more periods of demand data yields a more stable forecast. Using fewer periods of demand data gives you a forecast that is more sensitive to changes in demand. Take a look at the following data from the first week sales of ginger snap brownies. Now, let's compare 2-period and 5-period moving averages. Your 2-period forecast is equal to 53 plus 47, that is your last 2 time periods of demand, divided by 2, which is equal to 50. To calculate your 5-period forecast, you need to add up the demand for each of the last 5 days. That's 56 plus 54 plus 55 plus 53 plus 47, and divided by 5. You'll get 53. Focusing on the 2-period forecast, Kiana says, "Wow, sales are down. Maybe we should bake fewer ginger snap brownies tomorrow." Dallin, by contrast, thinks Friday's sales are an anomaly. He likes the 5-period forecast and argues for a baking schedule that looks more like the rest of the week. The more experience you have with your own demand pattern, the easier it will be to decide how many periods of historical data you want to use. Convinced that newer data is more meaningful, Kiana suggests, let's try the weighted moving average. She wants to place extra weight on the most recent sales data. Now Kiana and Dallin have 2 questions to answer. First, how many periods of data should they use? Second, how should they weight the data? Let's run the numbers for a 3-period weighted moving average and weight the periods as follows: 0.5 for the most recent data, 0.3 for the second most recent data, and 0.2 for the third most recent sales period. Remember, your weights need to add up to 1. Let's run the numbers. Your forecast will look as follows: 0.2 times 55 plus 0.3 times 53 plus 0.5 times 47. You'll get 50.4. If Kiana and Dallin are fairly confident this weighting pattern reflects future demand, they may not be too thrilled about adding ginger snap brownies to the fall flavors line. Finally, Dallin suggests they try exponential smoothing. Exponential smoothing weights your last period of demand with your last period's forecast. To decide on the weights, you need to decide how responsive you want to be to new trends. Let's look at 2 different scenarios. Scenario 1. If you believe demand variations are noise, that is temporary and not representative, you will place less weight on your previous period's actual demand and more weight on your previous forecast. Scenario number 2. If you think changes in demand reflect future trends, you place more weight on the previous period's actual demand. This weighting helps you catch trends early. In other words, scenario number 1 provides a stable forecast. Scenario number 2 provides a responsive forecast. The weighting mechanism is what forecasters call a smoothing factor, or alpha. The equation is as follows: forecast for time period t plus 1 is equal to alpha times your actual demand in time period t, plus 1 minus alpha times your forecast for time period t. Your smoothing factor alpha needs to be between 0 and 1. The larger your alpha, the more responsive your forecast will be to changes in demand. Let's calculate the exponential smoothing forecast for Saturday using 2 different smoothing factors: alpha equals 2, which will give you a stable forecast, and alpha equals 0.7, which will give you a responsive forecast. Let's run the numbers for an alpha of 0.2. Your forecast for Saturday is equal to 0.2 times your actual demand for Friday, which was 47, plus 1 minus 0.2 times 54. That'll give you 52.6. Let's take a look at a more responsive forecast using an alpha of 0.7. Your forecast for Saturday will be 0.7 times 47 plus 1 minus 0.7 times 54, or 49.1. Ultimately, the question Kiana, Dallin, and you need to answer is, how quickly do you want to respond to changes in demand? If you want to be a first mover, aggressively chasing demand, use a larger alpha. If you want to take a wait-and-see approach, use a smaller alpha. Now let's summarize. A forecast is your best guess about what will happen in the future. The more you know about your industry, your competition, and your customers, the better your forecast will be. Great forecasts help you meet customer demand at the lowest possible cost. Forecasts aren't perfect, but they're better than being blind.